Hello, I'm Victor Anderson. I'm the research manager at Colorado Space Grant in Boulder, and this is the video to accompany the basic driving module for the Colorado Space Grant Consortium's Robotics Challenge for 2020 and 2021. So, in a few minutes, we'll go through details of what the video includes. And then we'll get you building. So the idea of this video, hopefully this is an exciting video for people, because this is the place where you actually first get to put your robot chassis together and the driving board that you're going to use that allows the Arduino to control your robot. So finally, after working through how to solder and basics of Arduinos and so on, we're ready to actually build the robot and get it driving. All right, welcome to the basic driving video. We have some slides that go along with the video, and we're going to look at some of those now. It's a good idea, if you haven't already, to download these slides, especially for later on in the videos, because they make a good reference and they kind of guide you through the steps of the build in the same way that the video does, but with slightly different information or complementary information. All right, so what are we going to talk about today? Right, so the goals for this module are first to learn about the basics of how a motor driver, in particular an H-bridge motor driver, works, right? That's the board that we're going to use to actually control the motors on your robot, and so it's nice to understand how that, at least the basics of how that works. Then we're going to have you assemble your robot chassis and the motor driver board, and the motor driver board you need to do a bit of soldering on, but hopefully you've done or if you haven't already, you should go back and do the soldering video. Learn to solder video so you know how to solder. Then we're going to do some very basic driving with the robot itself, where we control the speed and the direction of the motors just to make sure we understand what's going on. And then at the end, we're going to program the robot to do a very basic driving maneuver. And then in later videos, we'll actually get more into more complicated driving and using sensors to control driving and so on. Okay, so the first thing we're going to talk about is what's called pulse width modulation, which is what we're going to use to control the speed of the motors. Right, it allows us to set a voltage between 0 and 5 volts from the Arduino board, and that's how we're going to control the speed of the motors. The motor driver uses a device called an H-bridge to control the motor direction, so that way the Arduino can just say drive forward or drive reverse. We don't have to go and rewire everything every time we want to change direction. Right, then we're going to do assembly. I'll talk you through an example of how to fabricate a little robot test stand. Some of the testing we're going to want to do here is going to be on a test stand, so that we can make sure that the robot is working before we actually set it on the ground and try to drive it. And then at the end, we'll do some very basic driving with the robot. Okay, so we've already seen with the Arduino in previous videos or previous modules how to turn devices on and off. For example, we turned on an LED, right? And that was relatively straightforward, right? We knew which pin the LED was wired into. We told the Arduino to set that pin's voltage output value to high, and it set that pin to 5 volts, and then that would turn on the device, in this case the LED, right? So in principle, it ought to be easy to turn on a motor as well. But the problem is with a motor, we want more than just on or off. We want to be able to control the speed potentially, and of course we do really want to be able to control the direction, because a robot that only drives forward would only be really useful, I think, in a one-dimensional world, and even there you might want reverse. And we want our robot to work in a world with more dimensions. So the question is, how do we actually go about getting the robot to control its speed and direction, right? So in order to control its speed, we use a technique called pulse width modulation, which is built into the Arduino. And then in a little bit, we'll talk about how to control the direction, which uses an H-bridge. Okay, so what is pulse width modulation, right? So Right, when we turn, again, as I mentioned, when we turn stuff on so far with the Arduino, we either set a high value or a low value, and that meant either 0 volts or 5 volts, or I guess 5 volts for high, 0 volt for low. By using pulse width modulation, we have more control. That is, we could set something to 2.5 volts or 3 volts or 3.7 volts. And we do that by adjusting what's known as the duty cycle of the pulse. Right. So what does this look like? Right. So as it's implemented on the Arduino, some of the pins actually are enabled with pulse width modulation, which means that the pin can very rapidly turn itself to high and low. And so if we tell the pin how often we want it to be high and how often it should be low, the overall effect is if we average out that voltage, we get an average voltage that's a combination of the high and the low, right? And in this case, the Arduino uses 8-bit resolution. That is, there's 256 possible pulse width states that we can turn a pulse width pin to, right? So for example, if we wanted the pin to be on 10% of the time, right, we would set a state of 25 out of 256, and we'll look at how to do this on Arduino in just a minute. That would mean 10% of the time we're on, 90% of the time we're off. So when we're on, we're at 5 volts. When we're off, we're at 0 volts. You average that out, and you get half a volt or 0.5 volts. Okay, if we wanted halfway to maximum 2.5 volts, we could do that by setting the pulse width to 127 out of our 256. Then we're on 50% of the time, we're off 50% of the time, and when we average out, we get 2.5 volts. And if we wanted, say, 4.5 volts, we could do that by setting our pulse width, for example, to 225, right? That would give us a 90% duty cycle, and that would set a voltage close to the maximum of 4.5 volts. Okay, so how does the Arduino actually achieve this? Well, the internals we don't really need to worry about, but the externals are actually pretty straightforward. The way that the Arduino works is some of the digital output pins it has are set up to be pulse width modulated pins. We can use them just like normal pins where they're always on or off, but what that means is those pins can also be set to a different voltage level, right? And how do you know which pins are the pulse width modulated pins on the Arduino? Right? If you look carefully on your Arduino, you'll see some of the pins have a tilde in front of the pin number, a little twiddle shaped thing, right? So in this case, if you look at this Arduino here, pins 3, 5, 6, 9, 10, and 11 all have that in front of them, and right, and you can actually see there's a little label that says that the digital pulse width pins are labeled with that. So on your Arduino, 3, 5, 6, 10, 11 are all pulse width modulated pins. It turns out what we're going to use a little later on when we actually use the pulse width modulated, we're going to set it up so pins 3 and 11 are the pins we're going to use, but we will talk more about that later. All right, so we can use pulse width modulation to control the speed of our motors. To control the direction of the motors, we need to use what's called an H-bridge, and that comes built in on the motor driver we're going to use, right? So how does the H-bridge work? What's the basic idea? Well, imagine we had a situation. So I've got a schematic here of a voltage source, a battery or something like that, right, with a positive terminal there, a negative terminal there. And the idea is over here, what is represented is a DC motor like we're going to use in the robots, right? So they also have a positive and a negative terminal. Right, and in fact, in wiring, typically when we look at these on our robots, the positive terminal is going to be wired with a red wire, and the negative is going to be wired with a black wire, right? So the idea is if we just wanted to hook up a motor to a battery, we could do that, right? And that battery or voltage source would drive the motor, right? And notice if we wired positive to positive and negative to negative, then that gives us a current path for current to flow, and in this case the current is going to flow basically from positive around this direction, right, into the positive, out the negative, back through the back through the battery, right? So we just get a circulation of current, And what that's going to do is cause the motor to turn. So in this particular example, we imagine that the motor might turn as we're looking at it clockwise. So what do we have to do to reverse the direction of the motor? Well, we need to reverse the direction of the current flow. And the easiest way to do that is, if we just had a battery and a motor, is to flip the polarity, right? So instead of having the positive polarity of the battery here and negative here, we just unplug it and replug it so that it's plugged in the opposite way. Right, so now negative is here up by the positive. We're connected to the positive on the motor. Positive is connected to the negative on the motor. That doesn't hurt anything, but what it does is it now means that the current is going to flow around this path in the opposite direction, right? So it's going to flow down, across, through the motor, the opposite direction, back, and back through the battery. And what that's going to do is, if the previous way of having that connected caused the motor to turn clockwise as we're looking at it, this is now going to cause the motor to turn counterclockwise, right? So the question is, though, how do we get this effect without having to constantly unplug and replug batteries, right? Well, the idea is an H-bridge. An H-bridge basically uses a set of 4 switches, and we're going to look at a diagram of one here in a second, that allow us to do that reversal of the current internally on the board, right? We just command the board to say, okay, now have the current flow the opposite direction, and it'll do it. Okay. So at least in a schematic, what does the H-bridge look like, right? So on the right side here of the screen, there is a schematic of an H-bridge, right? And so the idea is, and we need to identify some stuff on here. Notice the idea here is we're going to attach the positive of our battery or power source up on the top here, right? So motor power plus is up on the top. Down at the bottom is where we have connected the motor ground or motor negative terminal, right? So that's down here on the bottom, right? And then the idea is, in the middle of the H-bridge is where the motor actually connects in, and this is actually pretty straightforward. We'll see it just plugs into a board, right? But the motor still has a plus and a minus. And then the question is, sometimes to spin the motor forward, we want the current to go from the plus to the minus on the motor. If we want to spin the motor backwards, we want to go from minus to plus, right? And so the way that it turns out we can do this easily is if we have a set of 4 switches, right? So a high side and a low side on the left, and a high side and a low side on the right. And by having some of the switches closed and others open, we will give a current path through the motor that allows the current to flow one direction or the other, right? So let's take a look at how that might look. Okay, so for example, if I wanted to have the current flowing forward through the motor, right? So run it forward. I want it to go from the positive to the negative on the power. And so what I could do is close this high side on the left, which gives me a path from the positive to the positive terminal on the motor. And then I close the low side on the right, which gives me a path from the negative down to the ground. And so what's going to happen in this particular case is, once those 2 switches are closed, the current's going to flow from the positive to the negative through the motor, and that's going to cause it to spin clockwise. Okay, what if I want to reverse it? Well, then I need to have those 2 switches that I had closed open, and I close the other 2 switches. So I close the high side on the right and the low side on the left. Now the current can flow from the positive into the negative on the motor and out the positive. And so that's going to give me a reversed current, and the motor is going to spin in reverse. It's going to spin, in this case, counterclockwise, right? And I know this looks a little crazy on the diagrams, but it turns out wiring it and controlling it is really pretty easy on the Arduino. So we'll take a look at how to do that and start doing that a little bit later in the video here. All right, and in fact, just to kind of give you an orientation or heads up, the H-bridge we've selected is called an Ardu motor shield. It's made by SparkFun, relatively inexpensive, costs about $20. It has it has 2 channels, right? So it can control 2 motors, right? It's going to need it has some header pins that need to be soldered in so it can sit on top of the Arduino, right? So it sits right on top of the Arduino. We don't have to do any extra wiring. And then it has a few screw terminals, which is where we actually plug the motors in, right? And so we'll look at how to get that motor soldered together, that driver board soldered together, it's relatively straightforward. And that's what we're going to use to control our motors. All right, and here's a look at the H-bridge with all its parts soldered in. Right, so it's got a set of pull-through headers that allow us to plug it into the Arduino board, and then we could plug into the top, and those connections would go down to the original pin on the Arduino, right? And it's got those on the left and right side. And then there's the screw terminals which plug in and allow us to send current out. And the two channels it sends current out, it's not very helpfully labeled A and B, but we can just choose which side of the robot A drives and which side B drives. In fact, and one thing to notice here is because this is a shield, what this allows us to do is once the shield is plugged into Arduino, if we select pins, so if we select pin 3 and program it, or 11 or 12 or 13, and we're going to program all of those to do the motor speed control with the pulse modulated pins, and then the motor direction with just non-pulse modulated pins 12 and 13, we don't actually have to do any wiring because these headers are plugged into the Arduino, and so when the Arduino talks to those pins, that signal goes into the motor driver board, right? So in fact, one of the nice things here is once we've plugged the shield in, we have to wire out to our motors, but in fact we don't have to do any extra wiring. We're already wired in place like we need to be. Okay, so now we're actually at the point where you can actually start putting some stuff together so we can get the robot driving, right? So the first thing I want you to do, we're going to have you do, is put the motor driver board together. And as we've talked about already, and we've looked at that board a little bit, you need to solder some header pins on, the pull-through header pins that allow it to stack on top of the Arduino, and then there's two screw terminals that are where we're going to attach the motors that need to get soldered on, right? And an important tip here, right, we're assuming you've already done the Learn to Solder video, right, Soldering 101. And in that video, when we put components on the board, things like resistors or capacitors, right, they were pull-through through-hole components, and which is the same as the stackable headers. But in the cases in Soldering 101, we said bend over the legs to hold the components in place, right? So in Soldering 101, that's what we did. And then at the end, we said once the solder is good, we had you trim those legs off. We don't want to do either of those things with the motor driver board, right? Because the headers are pull-through headers. They're designed to allow us to stack and plug into the Arduino board below. So notice, first of all, if you bent those pins, you're going to have to try to bend them back when they're soldered. They're probably not going to bend back particularly well, right? So that's a bad idea. So do not bend the pins, right? Just keep them straight through the holes and solder them like that, so it's going to stack nice and easily. And of course, because the pins are designed to plug into the board below them, we also don't want you at the end of the soldering to trim any of those, right? They're designed to be these long things that allow us to stack. So right, so in this soldering, no bending, no trimming, and you'll be good. Okay, so how do you assemble that board, right? Or put those headers on, right? Well, SparkFun, it's not a video, but it's a pretty good step-by-step tutorial that shows you how the pins get soldered on. So I've given you the URL here, which is kind of long. If you want to work on your phone or another device, I also put a QR code that goes to that URL, that web page, right, and it goes right to where you need to be. You can read the rest of the page as well because it's got a lot of more information about the RG motor board if you want to learn more about it. But about partway down the board, that page, they walk you through how to get those things soldered on. Okay, so what's this going to look like once we've looked at the board already? A picture of the board with the headers and the screw terminals soldered in. So then the question is, how does that go on top of the Arduino, right? Well, if you've soldered things incorrectly, and just be careful that you've put the right, because the header pins have different numbers of headers, so just make sure you've put those correct ones in, and again, follow those instructions. When those are soldered on, they will line up with a block of headers on the Arduino itself, right? So the idea is we want to line those up carefully, right? Make sure that they're starting to plug into the rows beneath them on both the left and the right side. And then what you need to do is you need to push that board down until it seats, and we'll take a picture of what that looks like here in a second, right? These things, it's kind of a feel thing to me. Once I've got the pins lined up, what I want to do, it's a little counterintuitive because you want to push you might need to push kind of firmly to get the boards to the pins to go down into the headers below them. But of course you don't want to go crazy and push really hard to start with, because you might knock something sideways or bend a pin or something. So what I like to do is just I get it lined up. I start pushing slowly, and if it's not quite going in, I push a little more and a little more firmly, and eventually you'll start to feel that board slide down and kind of chunk into place, and that's what we're looking for, right? And this is what that'll look like when the H-bridge is fully seated, right? So it sits right on top. The pins are lined up, and then the terminals where we're going to connect are set up off to the side. Okay, so once you have your motor driver board, your RG motor board, all soldered together and seated on top of your Arduino, you can set that aside for a little bit, and we're going to go ahead and assemble the chassis, and then we can integrate those things on the chassis, get the motors plugged in and so on, and get ready to drive. Okay, so the chassis we're using for the challenge or these videos is it's by a company called Robotics. It's called like a Runt Junior rover or something like that. And there's a picture of what it's going to look like when it's fully assembled down here. Right. So in order to assemble your chassis, it mostly it's plastic parts mostly, and it mostly snaps together. You do need a Phillips head screwdriver to attach the motor boards to these side plates here, right? So you will need a Phillips head screwdriver to do that, but otherwise it just snaps together, and the wheels just plug on. You don't have to screw them on or anything. The manufacturer provides a short video about how to put the thing together, right? And again, I've given the link here, and again, a QR code if you want to snap that QR code on your phone or whatever other device you might be working with as well, and then it takes you to that video. It's about a 3-minute long video. It will take you a little bit more than 3 minutes to actually assemble the chassis. It generally snaps together pretty easily. Sometimes there is a little bit of resistance, so you'll just have to be careful and get it all snapped together. Take your time. If things don't seem to be going together correctly, I have a bad habit. I just tend to force things, or I'll get a tool or something. That's usually a bad idea. You maybe take a step back and say, oh, okay, wait a minute, what's going on, right? Because it's always better to spend a few extra minutes thinking about how it goes together and making sure you're doing it correctly than to force things and then break apart, which we don't want to do. And one thing to notice when you get the chassis put together, in the instructions, it goes through snapping most of the chassis together, getting the wheels, the motors attached, and the wheels attached. There are these 2 clips or braces that do plug into the back. It's not shown in the instructions, but you do want to do that as well. And these 2 braces are what are actually designed to hold our Arduino board with the motor driver on top. So we do want to, the way when you'll see my chassis put together, it's got that on there, and that's what I'm using to hold the Arduino in place. So go ahead and get that chassis put together, and then we can go on to the next step. Okay, so once you have your chassis basically assembled, one of the things you're going to want to do, and you can actually maybe do this during the assembly if you're careful as well, is we want to get the power wires for the 4 motors, right? Each wheel has a motor attached that it attaches to. But we want to pull those up to the top of the chassis, because that's the way I'm going to set things up. Right, and notice in all the pictures the picture I showed and all the pictures the manufacturer has, they tuck those wires under, so it looks nice and neat. But then the question is, well, how do you actually plug it into to anything when the wires are plugged under? So what I did is I pulled my wires, right? So for the motors on on each side through these holes here on the chassis. And it's a little bit tight and it is a little bit fiddly, but you know, I'm not particularly coordinated and I have fat fingers and things like that, but I was able to do it. So anyway, get those motor wires pulled up to the top of the chassis. And then what you can do is you can put your stacked motor driver board on top of your Arduino into those clips that we have attached to the back of the chassis, right? And so they can kind of they kind of slide in from the side is the easiest way I found to get in them. They and you just I just you know slid them around a little bit until I felt like they were relatively firmly seated. There they will tend to slide side to side a little bit, but that's okay, right? That's how they're designed to go. So anyway, that's going to put our driving board and Arduino on top of the chassis. We've got our wires pulled up to do power to the robot. Okay, so right, notice the Arduino motor board itself only has 2 channels to drive motors, but we have 4 motors. So how are we going to handle the fact that we have two channels to drive but 4 motors to drive, right? Well, what we're going to do is we're going to wire it so that the motors on each side of the robot go into a particular channel, right? So for example, if I've got it labeled here, so if this is the front of my robot and I'm on the robot, this would be my left side wheels and my right side wheels. So I wired it so that, and the instructions and code this is what they're expecting further on, is that we use channel A on the board to drive the left side wheels, and we're going to use channel B to drive the wheels on the right side. And you can see already, you know, with just the wires from the motors poking up, it starts to get to be a little bit of a rat's nest of wiring. Right, so one thing we can do to make that a little bit more manageable is instead of trying to bring all those red and black wires directly in to the motor controller board, which we could do, it does work to do that, but to me it's a little bit hard to follow. What I do, and this is what you'll see when my robot's running and set up, is I use my breadboard to bring the wires into. And then I'm just going to use jumper wires to go from the breadboard into the Arduino motor board, the motor driver board. And this, for me, the advantage is, I'm not trying to stick multiple wires into a single screw terminal, but also it just allows me to track more easily. And you know, what I found is I've needed to unplug and replug stuff a few times as I'm doing different things. And for me, this is a pretty straightforward way to do it, right? So how should you do that plugging in, right? Notice if you, for each row on the board, those are internally connected, right? As like we talked about earlier in some of the videos, right? So all these rows here, and then on the other side, these rows here are connected to each other, but they're not connected across the valley in the middle. And so what I did is I started with channel B. I brought my 2 ground wires, my 2 negative wires from my 2 motors on the right side of my robot in and plugged them into the same row, and then I plugged a black jumper wire in I'm going to take over and plug into one of the screw terminals on my motor driver board into channel B, right? And then I did the same. With a different row, I brought my red wires from the right side into my breadboard, and then I have another jumper wire that's going to go again into the Arduino motor board. In this case, I'm just doing some color coding. You may or may not have the same colors I do, or want to color code it the same way. In this case, I'm color coding green as channel B, right? So I've got a little green label and a green wire for channel B. And so that this black wire and this green wire here are the ones that are going to go to my motor board, and that's going to allow me to control the motors on the right side. And then, of course, you just need to do the same thing for channel A and the left side motors. So, a one row that has your ground with a jumper to go out and a different row that has your positive wires coming from the motors, and that's going to go into the final channel. Okay, so once you've got those things wired into the breadboard, you can bring those jumper wires over and plug them into your Arduino motor board, right? So this is looking down on my Arduino motor board, right? So channel B is my right side motors. I had a green wire as my positive, and so that goes into this plug label number 3. My ground for that same side of motors goes into 4. And then for my channel A, which is going to drive the left side of my robot, the black, my negative goes into channel 2. And finally, my yellow, which is connected to the red wires from the left side motors, goes into channel 1. All right, so it's got power or positive. The grounds, it turns out, get the middle 2 plugs, and then the last power for the other side gets plugged into the outside. Okay, so one last thing I wanted to do before we really started to load code and trying to drive our robots, even in a basic way, is I wanted to look through the code quickly. Right, so here is, we provide a piece of code called basic driving, right? So an Arduino sketch called basic driving, which you should have. If you don't have, go ahead and download it and you can open it up. And so the idea is this will allow us to do some basic driving, and then we can use this as a platform where we can modify the code to do more driving and different driving, right? So I just wanted to walk through some of the stuff in the code really quickly. It's a relatively straightforward piece of code, so hopefully when you look at it, most of the stuff looks familiar to you. Right, so the first thing we do is before we get into void setup or void loop, right, in the preamble part of our code, we set some variables, right? And these are just to keep track of the pins that are going to be doing various things, right? So we set those once at the top, and then we don't have to worry about it. We just remember what they're called, right? So in lines 10 and 11, we set up variables that where we code which pins are going to be the pulse width modulated pins. And remember, the pulse, these pins are going to basically, we're going to give these pins a pulse width level, and that's going to allow us to control the speed or the voltage we're supplying to the motors, right? So remember, we're using pins 3 and 11, and so pin 3 on the Arduino motor board goes to channel A, and pin 11 goes to channel B. So those are the two pulse width controlling pins, the two pins we're going to use to control the voltage setting. Then we need 2 pins that also go into the board, the driver board, that allow us to control the direction, right? And we just do that by setting high or low. And so it turns out those 2 pins are going to be pins 12 and 13. So we'll control, right? So here in code lines 14 and 15, we set up the direction for A. Channel A is going to be controlled by pin 12, and the direction for channel B is going to be controlled by pin 13. All right, so then we've set those variables up. We go into void setup, and remember, void setup runs just once, and so it's a great place to put things that you need to happen once at the beginning and never happen again in your code. So we set our 4 pins, right? The pulse width modulated pins A and B, and the direction pins A and B up as output pins, right? So that's what we do in lines 19 through 22. And then, like we have been doing, we do write some output just for diagnostic purposes to the serial port, or to the serial monitor, I should say, on our Arduino. And so we set our baud rate again at 9600. So we're going to write out using the serial line at 9600. Okay, so now we head down into void loop. And again, void loop, as we have already seen, this is the main part of your code. It's the part that loops over and over. Right now it's pretty basic. This is where a lot of work from now on is going to go into, and this part's going to get more complicated as we want our robot to do more complicated things. All right, so line 29, we just write out a diagnostic that says, oh, we're getting ready to drive. Then in lines 31 or 32 and 33, we set the direction of the motors to be forward, and we do that by setting the pins to high, right? So the idea here is high is forward, low is reverse, right? And that's the convention I'm going to use in everything. We could code it differently, but I like to make it so that high is one direction for both sets of motors and low is the other, right? So in lines 32 and 33, we set the direction to be forward by setting the pins to high. And then what we do is just run the motors at a couple different speeds, right? So the first thing we do is just try to run the motors on each side at full power, right? So we set, by using analog write, we set the value of the pulse width pin for channel A and channel B to 255, right? And remember those the pulse width modulated pins take a level, have 256 levels, so they take a value between 0 and 255. Right, and notice a useful tip is, if we ever want to shut motors off on one side, we can just set their value to 0, and that'll set them to 0 volts. But here we're setting them to 255, which is the maximum value, and that's going to set them to 5 volts, right? So lines 36 and 37, we turn both of those motors on to full power. We print something out to the serial monitor in line 38 to say that that's what we've done. And then we use the delay function, which we've used before, to have those motors run for 4 seconds, right? 4,000 milliseconds. So in line 39, we set a delay, and the idea here is the code is just delaying, so it's doing what it's doing up here, and it's not going to do something new for another 4 seconds. Okay, then finally, down in lines 42 through 45, we set the power to half power on those pins, right? So we use analog write again. Instead of being at 255 like before, we set the power to be 127, or the pulse width level to be 127, which is basically 50%. And so that should run us at 2.5 volts, which we print out to the serial monitor in line 44. We delay for 4 seconds or 4,000 milliseconds. Again, we're just going to run the motors at that speed for 4 seconds, and then we're at the end of void loop, so we go back and just keep repeating the thing. So when this code is running, you should see the motors run at high for 4 seconds, then half power for 4 seconds, then high for 4 seconds, and power half power 4 seconds. And right now we'll do it later, or we'll have you do it later. But right now we're just driving the motors forward. Notice if we wanted to drive reverse, we would set these values up here to low. One last thing before we actually start doing things with the robot is we do have a warning or a caution here, right, in those red letters to tell you that to be careful. Right, and that is, first of all, we provide a battery pack that eventually we're going to use to drive the robot, when it's in autonomous mode on the floor or on the ground or whatever. But we also can power the robot, right? We power the Arduino just through the USB port. And so one of the things you want to be careful of is don't ever hook up both the USB port and the AA battery pack at the same time. You'll get unpredictable results. It's not a good thing, and it's potentially dangerous to your hardware to do so. So we're either going to power through the USB or through the AA battery pack, but not both at once. And notice sometimes you're going to have to switch between the two as you're updating code and testing things, right? So. Right. The other thing is, notice once we give power to the robot, if it has code loaded on it, it's going to start running that code, and that doesn't matter whether it's getting power from the USB or the AA. So if we have some driving code loaded, and we plug that robot in, and it's sitting, say, up on the table connected to your nice laptop or your computer or whatever, it's possible that the robot's just going to start driving off because it's going to start executing a driving program. And so you always want to be really careful, or I want to be really careful. I'm always trying to be really careful. If I'm giving power to the robot, say up on the table connected to my laptop, that I don't want it set up generally that so it could drive. That is, I want to keep the wheels up off the ground or off the table. So one of the things that you'll see in the videos where I start testing, and I talk a little bit about how to make one of these, is I always like to make myself a little test stand, something that will hold the robot up in the air securely, but keeps the robots from out of contact from the ground or table. That way I can load code using the USB. I can watch how the code works. Are the motors driving like I expect? But the robot is not in danger of actually driving off the table. So just a warning is be careful when you power the robot, that you know that it potentially could start driving. So be thinking about what's plugged in, only USB or a AA battery pack, but not both at the same time. And that if you're going to have it plugged into your computer, I strongly suggest that you have a kind of a secure test stand that you can use to hold the robot up in the air, and that way you don't have any pleasant surprises of it pulling your laptop off the table or something like that. So we've put together our Robotics Runt Junior chassis here. My daughter put it together. It's just a snap together. You do need a screwdriver to do a little attachment, but she just followed the instructions on the little video that's online. So it's about a 3-minute video showing you how to put it together. It goes together relatively straightforward and easily. Then what I did is all the pictures they show online show it with all the wires for the motors tucked out underneath, which you can do if you really want to put your power source and components down there eventually. It's a little bit tight to me. So my plan is I'm going to work with the stuff I know I'm going to need to get to a lot on top of the chassis. And so I pulled the wires for each side of the chassis, or each side's wheels, up through these little openings here. And it was a little bit of fishing and fiddling around, and I've got kind of fat fingers and I'm not like really coordinated, but I was able to do it. And so now I've got my wires pulled up onto the top, and we'll look at how to attach those in a little bit. The other thing I did is, if you look at the chassis, these chassis are symmetric in a sense. That is, there's not a obvious front or back. And so in fact, since you drive the chassis forwards or backwards just by driving the wheels one direction or the other, you really just get to make a choice of what do you want to call the front of your robot. There's this clip on the back that's going to hold the Arduino board, and I decided I wanted to make that the back of my robot, and so that means this other side is the front, and it's not necessary, but I like to label things, so when I get further into the build, I'm not getting confused and I can see things easily. So I just labeled the front of my chassis so I know where it is. And the way I made my label, if you want to do this kind of stuff, is I just used some Post-it note and just cut a little bit of the sticky bit, so I wrote what I wanted to write, cut that bit out. So it'll stay stuck, but it's not like glued on, so I can pull it off when I want. And the other thing I did is we have our motor driver, our Arduino motor board soldered together, and actually it's sitting on top of the Arduino right now, but it just plugs into the Arduino. Right, so it seats on top of the Arduino with those header pins that pull up the pins to the top and also allow you contact to the pins, the board contact to the pins right to the pin. And it's got the screw terminals where we're actually going to send power out to the two motors. Right, and just a tip, in the soldering video with Bernadette, when we do those little soldering boards, one of the pieces of advice we give is like on the resistors or capacitors, is to bend the legs over to hold those in place on the board while you solder. Do not bend over the pins on these, because they're designed to go straight down and plug into the Arduino. And if you do that, if you bend them, you probably won't be able to get them bent horribly straight, and your board will never be quite the same again. And the other thing is, of course, there when we were done soldering with like the resistors and capacitors and we're sure we were okay, we would snip the pins off, or snip their legs off the bottom. And again, these pins need to go through, so please don't snip those headers. All right, so they just go straight through. You solder them on. We have instructions elsewhere about how to do the soldering on those pins. But then what I did is I've added the way we're going to wire this up is we're going to there's two output channels on the board. There's a channel A and a channel B, right? And so we can drive basically two motors or two sets of motors, but we have 4 motors on this chassis. So the way we're going to drive things on this chassis is we're going to drive the motors on one side with one of the channels, and then the motors on the other side with the other channel. And that basically we can do the tank tread style driving. That is, if we want to go forward, we drive we drive both sides forward. If we want to turn one direction or the other, we can drive one set in reverse and the other in forward, and that will allow us to turn or drive them at different speeds. We have a lot of control. But what that means is I've got two positive and two negative wires. Sorry, 2 positive and 2 negative wires on each side of my robot, but there's only going to be one set of terminals that both those wires need to go into. And you can do it. We've done it this way before, and it does work. But you could try to get both of the both black ends and both red ends into the terminals. But it's a little it's a little tight, and also if you need to take things off and put them back on, it gets annoying pretty quickly. So my plan is the way I'm setting it up is I'm bringing just jumper wires out, or connector wires from the terminals. I'm going to use a breadboard to plug my wires into and then bring the connecting wires in. So I'll have all my connections external out here where I can easily plug and unplug. And in fact, in doing this already, I've unplugged and plugged several times and I haven't been too annoyed by it. So what does that mean in terms of these wires? Well, we're using black is by convention in wiring the ground side or the negative side, right? And so for my pins that I've connected into, I'm using black for what is going to be the negative side on both of those for channels A and B. I could do red, right? Because red is positive, or is usually what we use for the positive on the power on a power circuit. But in this case, I wanted to do a little bit of color coding because I could already see as I was putting, it doesn't look like that many wires, but once you get them plugged in, it's like, oh my gosh, there's just nest of wires, and I'm not sure which wire is which necessarily. And so what I did to help myself out is I'm color coding the wires that go into the Arduino motor board, and then to the motors on one side or the other. The positive wires with a green for the B side and yellow for the A side. And that's just to help me keep track as I'm plugging and unplugging and things like that, what goes where. All right, and the final thing you might have noticed when I held this up is for my breadboard, I also made myself a little A and B channel label, so I know which side I'm working on, and I can see the color of the wires, but I've also just labeled for myself. And again, in this case, I was lucky. I had some yellow and green Post-it notes at home, so I could even color code my Post-it notes. Okay, so the next step here is I'm going to go ahead and attach my Arduino to the bracket on the chassis. I'm going to get my wires plugged into my breadboard with my motors, and then we'll talk about the next step of testing the first step of testing the chassis and how we're connected. All right, so I've gone ahead and attached my Arduino to the chassis, and I've wired up the motors the way I was talking about earlier. So there's the Arduino. Turn it around here as well. There's the Arduino with the Arduino motor shield just sitting on top of it. It can slide a little bit, but it's held relatively firmly in place, which is good. And then as I was talking about, I have wired the right side motors, again remembering the front of my chassis is over here, into channel B, and I've color coded that with green, and I've wired the left side of my chassis into channel A, and I've wired, as I've shown above, as I showed a little bit earlier. Now, before we start giving power to the Arduino and loading any driving code, I wanted to talk just a little bit about a couple safety measures you should take. The first thing is to realize when I plug the Arduino here in just a little bit, it's going to provide the USB bus is going to provide power to the Arduino, which means if I have loaded code that says to the motors that they should drive, they will start driving. And of course, it's attached to my laptop, like my laptop. And I'm working on a table. And so as you might imagine, having the robot actually able to drive while it's attached to my laptop is generally not a great idea, especially if I'm not expecting it to go driving and it drives off the table and who does whatever else that is probably undesirable. So the first thing is to realize that we're going to work on a little test stand here while I'm working plugged into my laptop. And in fact, for a test stand, I just did a little scavenging around the house. The first thing I actually tried is I grabbed a can out of the pantry, I grabbed a can of beans, and set the chassis up on top of that. What I discovered though is that the chassis, especially the bottom of the chassis, is pretty slick plastic, and on that metal can, it tended to slide around a lot, which I wasn't really very keen on, because having a test stand that is not secure is not a great idea. So what I did is I had some junk food. I won't tell you you'll have to guess the manufacturer and flavor of the junk food. So I had an empty can of a little bit of junk food. And so what I did is I just took a piece of paper towel, put it on the top, duct tape it in place. And now when I put my chassis up on there, he says, my chassis up there. All right, so I put my chassis up there, and it doesn't want to slide around. So I've kit bashed my little test stand here out of just stuff around the house. And we'll talk more about that in videos coming up. But, one of the things I encourage you to do is wherever you can, don't be fancy, scavenge and build to purpose with things you can find around the house. Okay, so I've got my chassis sitting up. And I'd been working with the driving code before, but I didn't want it to start driving immediately. So actually what I did is I uploaded to my Arduino, because remember, once you power the Arduino, whatever code is resident on the Arduino is going to start running. And so what I did is I uploaded the bare minimum sketch that comes along with the Arduino IDE. And in fact, it's normally, if you don't have anything else you've been working on, it's the sketch that normally opens up. And it's a perfectly legal bit of code, right? It just doesn't do anything, right? It's got empty loops. So when you compile it and upload it, the Arduino once it's powered, is going to constantly be running through those loops, but it doesn't have any executable code in there to execute. And so it basically doesn't do anything. So that's what I just did, that so I could save my robot before I actually uploaded the driving code. So I'm going to shut off here for a second so I can plug in my Arduino, then we'll upload the code and take a look at my first attempt at driving with the example driving code. Okay, so I have plugged my laptop into the Arduino. I've got the IDE open. I don't know if you can see. This is the basic driving code that we supply as an example to start working with. Right now the Arduino is powered, but again, it's running bare minimum, so it's not doing anything. So in a second here, what I'm going to do is I'm going to compile and upload the code, and then we can look at how this drives up on the test stand. And remember, this code, if we dig down a little further, and again, you should have copies of the code. It does a couple things, right? And again, the Arduino the board from the Arduino takes input from 4 different pins, right? 2 pins for channel A and 2 for channel B, right? So they're the 2 pulse width modulated pins, which are pins 3 and 11. We set those in the code, and that allows us to control how much power the motors are getting, right? By giving it a pulse width level. And then there are the 2 pins 12 and 13 that control the direction, right? And we set, right, what we've done in the code, I'm gonna scroll down a little bit here, is we've defined, we could reverse this, but we've defined so that if those direction pins are set to high, we want to drive the motors forward, and if they're set to low, we want to drive them in the reverse. So in the example code, we're trying to just drive forward, so we set those pins to high, and then we do some driving stuff where we drive at different powers, and then I've got a little delay in there, so it'll drive a little bit, stop for 4 seconds, drive for drive a little bit, and so on. Okay, so I'm going to go ahead and upload. I got to look at what I'm doing here. I'm going to just, I'm going to compile and upload, and okay, so you can hear I've compiled and uploaded, and my wheels are driving. But if you look at my wheels, and it may be hard to see on the video, but my right side wheels are not actually driving forward. They're driving in what I'm calling the reverse direction. The wheels on the other side are actually driving forward. And again, it's a little hard to tell from the video necessarily, but that is definitely what's happening. Okay, so what's going on? Well, it just has to do with the way the wheels are oriented on the chassis, and how it's put together, and so that's one of the first things to do, is check are the wheels driving in the direction you expect. I'm going to unplug the Arduino here just because it's annoying to have it continually running, and then I'm going to talk about how I'm going to fix this. Okay, so I've unplugged the Arduino. So notice we have a lot of options about how we can control the direction, right? Because it just has to do with the direction the current is flowing through those motors, which it causes them to spin the 2 possible directions, right? We could come into our code and say, oh, okay, I see my one channel is driving a direction I don't expect. So I'm going to now call for that particular channel, I'm going to call low forward and high reverse. We could do that. I'm not a big fan of that because I like to keep consistency in the code. So I always know that high is forward, low is reverse. So the way I'm going to fix it is I'm not going to touch the code. I'm going to leave the code alone. I'm going to come over, I'm going to, notice it was my right side, which is my channel B, right? So my green side. And I'm going to reverse up where I connect into the Arduino motor board. I'm going to reverse where the black and the green wire are screwed in, right? And so basically I'm just flipping the polarity between those 2 pins. And if and what that ought to do, and we'll test it here in a minute after I've done this change, is it ought to set us up so that I've now wired my robot such that that both will drive forward when I've coded like I've coded. So I'm going to make those changes and we'll take a look at what happens. Okay, so I have, let me stand up here so we can get a good look at it. I have reversed for my channel B, where the green and the black wire are plugged in, right? So I just switched the two from what we originally did. You can see I've actually plugged in and I've uploaded bare minimum. So it's not running right now. But now what I'm going to do is I'm going to upload my driving code again. Right, just basic driving, trying to drive forward. Compiled and uploaded, and now you can see that hopefully, it's a little, I always find it a little tricky on video to tell sometimes, but in fact now both sides of both sides of my chassis are driving forward, right? And that's what, the way I've coded it and labeled my code, that's what it said should be happening. So we're driving, and you can see also it's alternating back and forth between 100% power and 50% power, right, just by adjusting the pulse width that I give to the wheels. Okay, you know, the next thing we're going to do is we're going to just check and see that we can drive the wheels in reverse. Just, you know, just a quick check to make sure that things are working the way we think they should. And I know it's hard because I'm holding my camera and trying to type. With one hand. Okay, so I'm going to set, I've done it for that pin, and now I'm going to do it for the other pin. I'm setting both of these pins to low. And I know you probably can't tell what I'm typing because I'm jiggling around and typing with one hand, but there we go. I've done that. I've done that. I'm going to save my code. Right, and now I'm gonna upload, I'm gonna compile and upload. Okay, and now I'm driving the motors in reverse. So there we go. I have basic control. I know what direction my motors are driving. So the next thing we're going to do is we're going to attach, I'm gonna go back to forward driving. But I'm going to also attach the battery pack and let the robot drive on the floor, right? And I might say it a multiple times because it's very important to know that it is in general a really bad idea to attach, right? So here's my battery pack. It's really generally a bad idea to attach both the battery pack, the external power, and the USB at the same time, because both are now trying to power the robot. You could damage, well, you could damage things, including your laptop or your computer, and also you could get some unexpected results with how the Arduino operates. So you want to do one or the other. The nice thing about having our test stand is we can test out with the USB, we can load code and make sure it looks like it's doing what we're doing, and then we can unplug that, plug it into the battery pack and drive. So I'm going to go ahead and switch my code back to forward driving, right? I won't have you watch me try to struggle to type one-handed, but I'm going to go ahead and do that. I'm going to upload that code, and then we'll look at attaching. We'll look at attaching the battery pack and driving on the floor and seeing how that goes. Okay, so I have redone. You just went back and changed my driving code, basic driving code, to be driving forward, not reverse. Uploaded that, checked that it was working. I then unplugged the USB, so notice we don't have the annoying motor running all the time, and the USB is not plugged in, right? And the reason is here in a second, I'm going to plug my battery pack into my Arduino. It will start running that class code, which was loaded, which is the basic drive forward code. And then I'm going to set, I'm going to take my chassis over, set it down on the floor, let it drive around a little bit, and we can kind of look at how that goes. Okay, so, right, so, and again, it's hard for me because I'm doing this cell phone style. So what I'm going to do is actually, I can tell you, and I'll show you. I'm going to bring the battery pack up. I'm going to stick it underneath my breadboard, right, and with the wire coming out on the correct side to go into the barrel jack connector. And then when I got that situated, I'm going to go ahead and plug it in, and it'll start running, and then we can test it, right? So I'll let you look at the table while I do that really quickly. Okay, so you can see my battery pack's now resting underneath my breadboard. You can tell probably that I'm going to want to do a little fiddling here. I haven't plugged it in yet, but I have some extra cord, and I don't really want to have it in contact with the wheels or the tires there. So I'm going to go ahead and plug this in, adjust my cord a little bit, and then show you what that looks like. Okay, so we're okay. I mean, it's a little, it's running. You might notice that, in fact, the motors are running a little more vigorously than they did pulling power off the USB. So notice what that's saying is the USB bus on the computer could only apply a certain amount of current. So it was able to run, but in fact, it's able to get a little more current out of those the battery pack. So it's actually running a little bit better. I'm gonna stand up, grab my robot here, trying not to touch the wheels as they're going. Okay, and I'm gonna bring it over and set it on the floor. So there we are on the floor. I'm driving through my house. The cat is wondering, what the heck is going on? What should I do about this? She's did pretty well. Okay, and I've run into stuff and stalled, and was going a little quicker, but that was okay. All right, so it's driving, and it's able to drive on the floor. So I'm gonna unplug this really quickly so it stops running, and then I just wanted to talk a little bit about what we were seeing there. Okay, so notice a couple things happened. One is that it didn't do too badly, but it didn't drive 100% straight, right? And so what's going on, of course, is in part the wheels may not be perfectly aligned. In fact, for a under $30 chassis, maybe that's way too much to expect. But the other thing is it may not be providing exactly the same amount of power to the wheels on both sides. Right, even though it's, nominally it should be, but in real world maybe it's not. And so one of the things we can do, or you can do with your robot, and I'm going to ask you to do a little bit later here, is test out how straight is the thing driving, and maybe make some small adjustments in your code. Maybe instead of driving, both at exactly 50%, for example, if you're trying to drive at 50% power, you might need to drive one at 47% side, it's 47%, the other at 50%, and that'll have you drive straighter. Notice the other thing is that this is not a super powerful robot chassis, right? So we got run up against something sitting on my floor over there, and the motors continued to try to run, but they were not able to. That is, they basically, whatever they ran into was exerting enough torque on the wheel that it was not able to overcome that torque and turn the motors. So, right. So on motors, they talk about having stall speed or a stall current or something like that. And so one of the things is, and it's for us, the way this the challenge is designed, it's probably not going to be a big deal, but just realize that these robots are not super powerful. if you wanted to take them into outdoor applications where they had to do hill climbing or stuff like that, one thing we could do is provide a different external battery pack that might give us a little more power. But often what you really need to do is just upgrade, right? And maybe not upgrade this chassis, but upgrade to more powerful motors and things like that in the future. But for us, this is perfect, right? So we're running, we're driving more or less straight. And the next thing is to do a little bit more coding to control the driving. All right, so now your robot should be driving successfully. We've got control of the power that the motors are driving with, and we know how to drive forward and reverse, and we verified, or hopefully you verified that it's doing that all right. So the last step in this module is to code slightly more complicated driving. Not very complicated, but we'll do that in the modules that follow. But we just want to code a slightly more complicated driving so we can start to see how how we have to modify code to get the robot to do different things. Right. So what I want you to do, or what I want everybody to do, is take the basic driving code and make a copy of it to work on, called basic driving forward reverse. Right. So the idea is we'll leave basic driving in its basic state in case we need it later, and that we'll make some more modifications to this new piece of code. Right. So once you've got a copy of that code, open in the Arduino IDE, what you need to do is to modify the code to do the following. First of all, I like to add in, if I'm going to be driving much on the floor, notice as soon as, if we have driving code, the basic driving code loaded, as soon as we provide power to the robot, at least for us as humans, very quickly, the motors start driving. Right, so that's okay. If we've got it on a test stand, we're powering it with the battery pack, we can pick it up and set it on the floor. However, I like to code in a time delay at the beginning that gives me time to plug the if I've got it set down on the floor or something, to plug in my battery pack, have the robot sit there for a bit before it starts driving off. So what I want you to do is, first of all, just code a relatively long initial delay. I somewhere between 10 and 20 seconds works pretty well for me. And notice we just want to do that initial delay one time only, right? This is just to give us time to set up the robot, get it plugged in, and get it set up like we want before it starts driving. So we want to do that one time only. Think about how you might get the robot to do things one time only at the beginning. Then I want you to program the following sequence. 4 seconds of driving forward, and you can choose the power. You could do half power, full power, or somewhere in between. Right? But have the robot drive forward for 4 seconds. Then I want you to have it pause. Right? I want you to shut both motors off so it just sits there for 4 seconds. Then drive in reverse for 4 seconds. Do another pause, and then, right, if this is in void loop, just you're at the end of void loop, have it repeat, right? So the idea here is code this sequence of driving, and it's probably a good idea. I always like to test it out on the test stand first to make sure the sequence is what I expected it to be, and then go to the floor or the ground and have it drive that sequence. Right, so upload the code, test it on the test stand, then once it seems like it's working, go ahead and use the battery pack to have it drive that sequence on the floor and see how it does. Okay, so what do you need to do to advance to the next level, right? Well, that last sequence of driving is what is the most important thing for advancing to the next level. So, right, so post a video showing your robot doing that driving sequence to your portfolio, right? Either a link or onto the portfolio itself, and then like we've been doing with others, post a link to your results to Discord so everybody can see it, and then congratulations, you've got a driving robot that we can actually start doing some more interesting stuff with.